Morning. Well, first lesson of our quarantine. Yay. Alright, so let's get right down to it. I hope you guys are doing alright. I miss you guys. Hopefully I get to see you guys sometime soon. Alright, so what we're dealing with today, and probably this whole chapter, is going to be just formulas. Okay, the use of formulas to solve for area, surface area, or volume. Today's lesson will just be around finding the area of a parallelogram, a triangle, a trapezoid, a rhombus, or a kite. And really it's just how well can you use these formulas. Either you're going to use them straightforward, or you're going to have to solve for a piece. You know, if I give you the area, I want you to find the length, or if I want the area, you're going to have to use the length and the width, depending on the object. So let's look at the top three. Right here on your first page, you have parallelogram, you have triangle, and you have trapezoid. You have three formulas right there. The most important part of this is to make sure you know what you're dealing with. If you have a parallelogram, you're going to have to look for the height. Here is your equation right there. Then you have your triangle. You should already know that one. It's a 1/2 base times height, or base times height divided by 2, right there. And then you have your trapezoid. This is a new one. We've been dealing with this. The trapezoid has two bases. Okay. Let's see if I can get this to. There we go. Alright, so we have first base right there, and then we have our second base right there. So that's base 1, and that's base 2. You have those two, and you have the height. You should just put those in a calculator, and you can find any online calculator. Actually, if you tilt your phone over, your phone will expand its calculator by itself, and you can use that one accordingly. So there's that formula. Alright, so let's go into our examples. We have our first one right here, area of a parallelogram. You have it in front of you. This is 6 inches height, 10 inches on the base. So let's do this. You have your area equals base times height. Which means your area, this is height, that is your base. So area equals 10 times I'll just put the X, 6. So the area is equal to 60, and let's put in the units, inches squared. Let's go to one that we know. Rectangle. Now this is where I would ask you guys, hey, does anybody know what the formula for the area of a rectangle is? And some of you would raise your hands and you would say, oh, it's same thing, base times height, or length times width. Well, this is 1. We're going to have to work backwards. Okay? Notice how they give us the area. There. and they give us the width right there. Alright, so we know that area is equal to base times height. We know the area is 136, and we know the height is 8, but we don't know the base. Divide by 8, divide by 8, and we get our answer. $17 millimeters. Even in quarantine, I make mistakes. Base equals 17 millimeters. Okay, we're back. We're on number 3. Now we're going to deal with the trapezoid. All of this is just formula usage. How well can you use these formulas? So, for a trapezoid, if you notice, we need to find out the basis and the height, and then we get to use that nice little formula. So we need 2 bases and a height. Let's see what our problem has. Sure enough, we have 2 bases and we have our height. So here we have base 1, here we have base 2, and here we have our height. So our formula area equals 1/2 add the 2 bases and times the height. So area equals 1/2 times 11 plus 15 times the height is 7. One-half, that would be 26 times 7. And if you put this in your calculator, this ends up being 221, if I'm correct. Let me use my own calculator because I am human. So 0.5 times 26 times 7. Good thing I didn't go with my number. 91. So the area equals 91. Let's use units. We're dealing with area squared. Let's go with a triangle. But I believe this one is also a reverse problem. Notice how they give us the area. So we're going to start off with the area, and we're going to have to solve. Area of a triangle one-half base height. all those multiplied. They give us the area, and guess what? They give us the base. So we're going to solve for the height. Alright, let's see what we can do here. So, area, let's back up, let's just fill it in as it is. We have 192 equals, and we have the base, which is, we have 1/2 times 24 times the height. These two we can multiply together, so we get 192 equals 12 times the height. Then we just divide by 12, divide by 12, and our answer ends up being 16 centimeters squared. Let's move on to our rhombuses and kites. Nothing really is going to change besides the fact that, we need to look at the formula for a rhombus. We need to look at the formula for a kite. So let's go ahead and do that. Let's, for you, it'd be turn the page. And for me, it's just trying to maneuver around this darn app. So here is the rhombus formula. Rhombuses have two diagonals, here and here. Here is my formula for the rhombus. Area is 1/2 times the diagonal, one diagonal times the other diagonal. Simple enough. Hey, guess what? The kite is the same darn thing. Both rhombuses and kites have the same area formula. So, let's dig right in. As long as we have the two AC, BD, guess what? We just need to plug in our formula. The area is 1/2 times the first diagonal times the second diagonal. So my area is 1/2 times 14 times 10. If I put all of that in the calculator, my area ends up being 70. I know it's not Spanish class. 70 centimeters squared. Ooh. Our kite on number 8 is missing a diagonal, so we're just going to have to reverse it. We already know the formula. We know that the area is equal to 1/2 times the first diagonal times the second diagonal. They give us the area. That goes there. So 414 is equal to 1/2 times 23, and they want to know one of the diagonals, and they're saying diagonal 1. Awesome. There are decimals here. Alright, so this becomes 414 is equal to 11.5 diagonal 1. And we just divide 11.5 divided by 11.5, and we get 1 is equal to, and 36. Let's try. Number 9 is the same. We're reverse engineering the formula. Give us the area, which means we need to find our diagonal. Let's see if I can. So, we know the area equals 1/2 d1 times d2. That's 90 is equal to 1/2 times 15 times d2. Okay, so there will be decimals, so this is 7.5 times d2. We're left with division. Our answer will be, actually, not area, it will be our diagonal. And that will be 90 divided by 7.5. I'm sure you guys are asleep already. 12 meters. Alright guys, hopefully these notes have kind of helped you. If it has not, please send me a private comment on the assignment so I can help you with it, or I can send you another mini clip of what needs to be done. Send me a picture of what you need or a problem you're having, and I'll be glad to work it out with you. I know this is new for both you and myself, so I'm gonna work with you guys. So let's get this done. Till tomorrow.